Okay, in today's video, we are going to learn how to find the distance between a line and a point not on the line. So first of all, we need to create line L. It has points. Let's see here. Pick red. Okay, it has points 1, 2, and 5, 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And there's a line going through it. Actually, let's use that color. That's the line going through it. Okay? Now, we want to construct a line perpendicular to L through P17, excuse me, 1, 2, 3, 4, 5, 6, 7. Okay? We want to create a line going through that that's going to intersect this, and we want to know the distance. So we have to find the point of intersection of this line that we're going to draw here, excuse me, and then find the distance between the two. So first off, let's look at this first equation that we had. I'm going to keep this in red. And the first thing we want to do is find the slope so that we can then write an equation of this line. So the slope is positive. I'm going to subtract this way. So 4 minus 2 is 2. And 5 minus 1 is 4. So the slope of this line is 1/2. Now, I want to write an equation. So I'm going to start with point slope form, y minus 2. I'm just going to use this first point. I could use either x minus 1. So y minus 2 equals 1/2 x minus 1/2. I'm going to add 2 to both sides. So y equals 1/2 x negative 1/2 plus 2 is 1.5, or as a fraction, that's 3/2. Okay? And that does look like that's what this line is going through. Like it's going through probably about 1.5 on the y-axis. So I'm going to erase some stuff here in a minute, so I want to make sure I have my equation. Have that over to the side. Now I need to come up with an equation for my blue dot that's going to become a line through that point, and it's going to be perpendicular to this. So when I'm talking about lines that are perpendicular, I need the negative reciprocal for the slope. So if 1/2 is the slope of this, the reciprocal of 1/2 is 2/1, and the negative reciprocal is negative 2. I'm using 0.17, so y minus 7 equals negative 2x minus 1. Y minus 7 equals negative 2x. Negative 2 times negative 1 is plus 2. I add 9 to both sides, and I get I add 7, thinking that it's going to be 9 in my head. I add 7 to both sides, and I get y equals negative 2x plus 9, which means my y-intercept will be 9. I'll go down 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. So I can actually see by graphing, well, hold on a second, I'm jumping around here. Let me write this equation over here, just in case I need it for later, and that's negative 2x. That by graphing, I can see that the point of intersection, erase all this, is going to be 1, 2, 3, 1, 2, 3. That's their point of intersection. I want to go over, though, how I would solve that algebraically if I didn't know that. So since they're going to have a point in common, I can solve a system of linear equations where I take these two equations and I set them equal to each other. Okay? Now, I have fractions on this side, fractions on, and no fractions on the other side. I don't really like the fractions, so I'm going to clear the fractions. Since the least common multiple of the denominators is 2, I'm going to multiply everything by 2. 1/2 times 2 is 1. 1x is just x. Okay? 2 over 1 times 3 over 2, multiply the numerators. 2 times 3 is 6. The denominator is 2. 6 divided by 2 is 3. 2 times 2x is 4x. 2 times 9 is 18. I'm going to subtract x from both sides. Sorry, I did something wrong here. Maybe this is going to work. I subtract x from both sides. I'm going to get 3 equals 3x plus 18. Well, this is going to work. I get it's minus 18. No, I did something wrong here. 3, because I can see that my point of intersection is 3, 3. So let's back. Oh, you know what? When I did this, I knew this was going to happen. I wrote that -2 up there, and then when I copied it, I didn't see it. That's what happens when I get sloppy. That should be -4x. So let me rewrite this. Say it all the time. When I get sloppy, I make mistakes. It was y equals -2x plus 9. If you're watching the video, maybe you caught that and said, oh no, Mrs. Falk. So now, back to my black pen. I add 4x to both sides. Now I get 5x plus 3 equals 18. I subtract 3 from both sides, so 5x equals 15. X equals 3. That was what I got. Now I could plug the 3 into either equation. I'm going to plug it into this one because it has no fractions. -2 times 3 is -6. -6 plus 9 is. So the point of intersection is 3, 3. So I'm going to erase all of this. Don't need this anymore. Okay. Get that all erased. So now I know that the closest distance between this point, right, 1, 7, and this point, and this line is on this point. So I have point 1, 7 and point 3, 3. I'm going to use the distance formula. x2 minus x sub 1 squared plus y2 minus y sub 1 squared. So 1 minus 3 squared plus 7 minus 3 squared. Let me check that. It doesn't matter which one you use first or second. So 1 minus 3 squared. 7 minus 3 squared. Okay, plug that in right. 1 minus 3 is -2. -2 squared is 4. Plus 7 minus 3 is 4. 4 squared is 16. So it's 4 plus 5 squared, right, square root of, sorry, let me back up. 4 plus 16 is 20. So we are looking for the square root of 20. If I want this in simplest radical form, that would be 4 times 5. So in simplest radical form, it's 2 radical 5. If I want it rounded to the nearest tenth or hundredth, I need my calculator. So 20 square root, a little bit more than 4 is the distance, about 4.47, and that's how you find the distance between a point and a line.